In this video, I will show you how to analyze confounding and interaction using SPSS. We use dataset called ISOP_HIV, and we collected data. This is actually real data set from one of my collaborative studies. We collected data from 306 patients, and outcome variable interest is F2 isoprostane variable. F2 isoprostane value measuring level of antioxidative stress. That's this variable. And in this exercise, we want to assess effective BMI after controlling for smoking. Let's use current smoking. Age and sex and CD4 counts. So let's use linear regression. Okay, so outcome is isoprostane, and independent variable is BMI, sex, CD4 counts, smoking, and age. Okay, you want to see effective BMI adjusting for sex, CD4, smoking, and age. Okay, so we want confidence interval, and continue, and then click OK. Right. And before we check output inlets, just in case, perform residual diagnosis. So we've got plots, histogram normality plots, Z-pred and Z-rated here, and continue. Okay. And in fact, residuals are skewed, so I think we better transform outcome variable. Right? So I'm going to create log, natural log of isoprostane level and isop. Okay. And let's repeat analysis. And include a log of isoprostane. Okay, just click OK. Now residuals are beautiful, beautiful, good. So we can look at the result. Effective BMI is statistically significant, and beta coefficient is 0.013. And now our task is we want to identify what is the strongest risk factor, what is the strongest confounder among these four variables. Okay. And now let's look at the result. P-value for BMI is 0.006, and this effective BMI is adjusted for sex, CD4 counts, current smoking, and age. Okay. And our task now is we want to identify which one of these four variables are strongest confounder on association between BMI and F2 isoprostane. And in order to do that, we will conduct analysis by excluding each of these covariates. Okay? And for example, if we exclude a sex from this, the effect for BMI would be non-sex adjusted. So we compare difference between non-sex adjusted BMI and sex adjusted BMI, and then we compute percent change in terms of unadjusted sex unadjusted BMI. Okay, so let me do that. So you go to Regression Linear, and to see if the sex is confounding association of BMI, and we get rid of sex from the model, and then run the analysis. Actually, don't need residual plots anymore. Okay, so after we exclude sex, effective BMI become beta coefficient for BMI become 0.017. So it was 0.013. Thus, we can say sex is confounding the effect of BMI. Okay, so we just have to repeat this 3 more times by excluding CD4 smoking age 1 at a time. Okay, and let's do that. And go back. Okay. So we put the sex back and remove smoking, and let's run analysis. So now smoking unadjusted effect is 0.011. So instead of using 0.017, and you use 0.011 to compute percent difference. Okay, so you repeat this 4 times. And confounding, and the biggest confounding factor can be determined with the variable giving largest percent change. This is actually the table we published in this paper. So we included actually a lot more variables in the model. So we adjust sex and smoking, BMI, current NDP use, age, CD4 count, race, antioxidant use, viral load, and total cholesterol level, and current EFB, D4T, GDP, and PI, protease inhibitor use, and presence of depot atrophy. And so, effect of each of covariate, each variable is adjusted for all other variables included in the model. So if you look at effect of BMI, an effect of BMI is indicated 1.06. Remember, outcome is log transform. Therefore, we take exponential of that. Okay. Remember, outcome is log transform. So we took exponential of beta coefficient, and then we convert it to relative increase. So this means by every 5 unit increase in BMI and 6% increase in F2 isoprostane level, and result is statistically significant. And this is adjusted for all other variables. Adjusted, what adjusted means? Independent of all other variables. What independent means? Regardless of all other variables. We said effect of BMI is 1.06, 6% increase in F2 isoprostane by every 5 increase in BMI, regardless of age in smoking, race, CD4 counts. Although, how do you know the effect is the same regardless of, for example, age? Did you really look effect of BMI within a group with younger age or older age? So let's perform subgroup analysis assessing the effect of BMI within a patient whose age is 40 or greater, or those who less than 40 years of age. Okay? So first we need to create age variable. So let's go to compute variable, and we create age 40 and say age greater or equal 40. So this returns 1 if expression is true, otherwise it returns 0. And you click compare groups, and then you put age 40. Okay, and then click OK. And all the analysis you conduct after this point will be performed separately within age group. So we want to assess effect of BMI, so go to Regression Linear. For simplicity, let's not worry about adjusting for other variable. Okay, so for this analysis, let's use BMI and unit being 5. Okay, so instead of original BMI to be consistent with the result in the paper. So let's go to regression linear, and we put the log of isoprostine dependent variable and BMI 5, and which has a 5 as a 1 unit in the independent box. Okay, and then click OK. So among younger group, beta coefficient is 0.081, and among older group, beta coefficient is 0.064. And you can see effect of BMI is slightly higher and among younger age group. And I'm not sure if this difference is biologically meaningful, but I'd like to show you how to assess differences in two slopes. So let's assume these are meaningful difference, and then we put a p-value to compare these two slopes. Okay, so that's the interaction analysis. Okay. And in linear regression linear, and there is no automated option to create cross product term between BMI 5 and age. So what we need to do is we create by hand interaction term, and that interaction term I call it BMI age, and which is simply cross product term between BMI 5 and age 40. Okay, and in linear regression, and you include this cross product term, and here is a rule. And when you include interaction term, you need to include main effect. So you need to affect age 40 and BMI 5 themselves too. And let's click OK. And as we thought, p-value for the interaction term is not statistically significant. Therefore, we conclude there is no interaction, or interaction was not detected. Okay. When you include interaction term in the model, and explanation of parameters can be a little bit tricky. So beta coefficient for BMI main effect is 0.081. So this is effect of BMI among younger group. Okay. And then if you want to have effect of BMI for older group, and you simply add these two up. Okay, so that becomes 0.064. And in fact, minus 0.017, which is beta coefficient for interaction term, is the difference between these two. And this p-value statistically assess this p-value. Statistically assess, actually it's not here, it should be here. Statistically assess whether this difference in the slopes is different from 0. In this case, we didn't reject the null hypothesis that we couldn't say this is different from 0. Right? So let's move on. When interaction term is clearly not significant, and you may drop the interaction term from the model, okay, and go ahead to click OK. And what this analysis just did is you adjusted effective age when you assess effect of BMI. So effective BMI, age-adjusted effective BMI is now 0.072, and this is in fact average between and two age stratified effective BMI, so 0.064 and 0.081. And your result would be like this. After we adjusted for effective age, an independent effect of BMI is 0.072, okay, and which is statistically significant. So that means regardless of age, if you are younger or older, doesn't matter. This is the effect of BMI. So let's explain this beta coefficient as you explain this in the paper. And a fact you can't forget is outcome variable is log transform. Therefore, we had to anti-log this value. So if we anti-log, okay, and this become 1.075. So this means there is 7.5 increase in F2 isoprostane by every 5 increase in BMI. And that was statistically significant. In fact, from this point, we may start using different options to do linear regression. If you do general linear model and univariate, okay, and this mathematically does the same thing as linear regression, although it's very easier to use because you don't have to create interaction term by hand. So let me repeat analysis we just did. Outcome variable is log of isop. Put it here. And then GLM options. You actually have more than one box to include independent variable. Forget about random factor for now and wait for now. Any continuous variables, continuous independent variable will be included in this box, and categorical independent variable will be included in this box, except when you have a binary variable, you can include those binary variable in here. And I recommend you to use 0-1 coding for your binary variable, and interpretations of beta coefficient will be easier. It doesn't affect on p-value, but it's easier to use. So in this case, BMI 5 is a continuous variable, so we put it in a covariate box. And age 40 is a categorical variable, although we code it 0-1, so you can either put it in here or you can put it in here. And let's put it in here. Okay, and then you click on model, right? Click on custom, and here you set this to main effect, and you can put this one at a time, or you can highlight both and put both at the same time. And here's a trick to create interaction term. So you click interaction and you highlight both, okay, and then put it in that box. So this is how you automatically compute it, create interaction term. Okay, so click continue, and go ahead to click on option, and then we want parameter estimate. Without this, we can't have beta coefficient. Okay, all right, and then continue. All right, so this is a result of a GLM, or linear regression you can call, and it's the same as what we got from regression linear option. Okay, so this slide summarizes steps to assess interaction. So first, include cross-product term in the analysis. And if the interaction term is statistically significant, okay, and report there is interaction. That means two slopes effective BMI is different between age groups. If the p-value for interaction is not significant, drop the interaction term. In fact, you need to also assess clinical significance as well. Okay. So sometimes, or many times, interaction analysis is underpowered, so clinically meaningful difference may not be detected. But anyway, when you judge effect of BMI is similar between two groups, and you conclude there is no effect modification or interaction. Okay, and still it's very early to ignore age from analysis. So you may assess whether age is confounding or not in your analysis. Okay. So how do you do it? And you run the analysis including age and BMI, and that gives age-adjusted effect of BMI. And then also conduct analysis just including BMI in the model, and that gives unadjusted effect of BMI, and then compare if two effects differ. If it's different, and you may conclude age is a confounding factor on the association between BMI and F2 isoprotein.